All right, so 5.4, more sum and difference formulas, but we're going to specifically look at the sine and the tangent function. All right, for sine of a plus b, I could just tell you the formula, but that's not interesting, right? So let's make it fun. Let's derive it. We use a cofunction, right? So we know the sine of some angle is equal to the cosine of the complement of this angle. So the complement of this angle is 90 minus a plus b, right? All right, now A and B are still angles, right? So if I have minus those two angles, I'm going to distribute the negative across. So minus A, minus B. Now from here, I know that from the previous section, I know the cosine of the difference of the two angles, right? Well, I'm going to group 90 minus A. So now 90 minus A, that's one angle, and B is one angle, right? Still got three angles in here, but grouping two together, the sum of those two is still an angle. All right, so now I apply my cosine of the difference of two angles formula. Cosine of the first times cosine of the second, which is the B. Change my sign, so it's going to be plus. Sine of the first, 90 minus A, times sine of the second, B. Now from here, I'm going to change these back into their cofunctions. This one has its cofunction. So the cosine of an angle is the sine of the complement of this angle. Well, if 90 degrees minus A is the value of, say, 50 degrees, A must be like 40 degrees, right? So this is just A, sine of A. Times the cosine of B. This is going to be the cosine of A. And this is the sine of B. So there is your sine of A plus B. Formula. I'll derive from the cosine formula that we just did. So now you can pretty much guess what the sine of A minus B would be. Exact same format, except the no longer a plus, minus separating the two products. All right, so I've given you two more formulas to memorize, right? Yes and no. You do them enough times, you automatically just start memorizing them. Every single problem you get, write out the entire formula, right? And that way, just writing it out by habit, you're going to know what it is. But I like to save my formulas in more words instead of just what I see. So like if I see this one, I say sine of A plus B is sine of A, or sine of the first, I don't care what variable I'm looking at, sine of the first times cosine of the second. Keep my same sign, so it's minus or plus, I keep the minus or the plus, and then cosine of the first, sine of the second. And one visual way to look at this, if I'm looking at sines, sines are on the outside. Right? And this sign here is the same sign. For the sign of a plus b or a minus b. So it's just a little way I think same sign, signs on the outside for the sign of sum and difference formulas. Lots of S's in there, right? All right, so before we do an example, let's go straight into the tangent formula. Because then we're going to do one example is finding the sine and also the tangent of two angles. So the tangent of a plus b. We can go ahead and derive this one too. Because now tangent of something is the same thing as sine of something over cosine of that something, right? Tangent of x is sine x over cosine x. Right? So this is going to be sine of a plus b over cosine of a plus b. Just your quotient identity. Well, we now know the formulas. Sine of a plus b, sine of the first, cosine of the second. Same sign, so it's plus cosine of the first, sine of the second. The cosine of a plus b, cosine of the first, cosine of the second. Change my sign, so it's minus. Sine of the first, sine of the second. All right, so I can leave it like that if I wanted to. Let me tell you, that's not making anything look as nice as I think it could be. So what I'm going to do, this magic number is going to just fall out of the sky. This magic number is 1. Remember, I gave you that hint last time with establishing identities. A lot of times, if you want to manipulate a fraction, perhaps you want to multiply it by 1, right? Top and bottom by 1. 1 takes on all different kinds of forms, right? Which form will I choose? And you're going to say, why in the world would I choose this? Something this complicated. You're going to see after I distribute this to the numerator to each term and the denominator to each term, what will happen? So I would get this times that. So I have sine A cosine B over cosine A cosine B minus cosine A sine B over cosine A sine B. Notice these cosines cancel in that first term, sines cancel in this second one. That's my numerator. My denominator. Oh wait, I messed up somewhere. This is not that. Where's my eraser? This should be cosine A, cosine B. So the cosine A's cancel out, right? All right, denominator. Cosine A, cosine B, all over cosine A, cosine B. Minus, this is a plus 2 right there, messed up. The numerator is this plus that, denominator is this minus that. So we got sine A, sine B, over cosine A cosine B. So we go simplify a little bit in the denominator. Cosine A cancels. Cosine B cancels. Now we rewrite everything. Notice we have sine A over cosine A. That is tangent of A, right? Sine B over cosine B. That's tangent B. All over. Everything canceled here. So that's just 1, right? Same thing over same thing. That's 1. Minus, well, if I split this up right here, split it up. This fraction times that fraction, that's tangent of A times tangent of B. So this is your tangent of A plus B formula. All right, so very similar. Tangent of A minus B. So if you know your sum formulas, you should know your difference formulas. It's all the same terms involved. It's just the signs in the function or in the formula are different, right? Instead of pluses here is minus theirs. Minus is here is plus there. So this would be tangent of A minus tangent of B all over 1 plus tangent of A times tangent of B. All right, so we've got all our sum and difference formulas for sine, cosine, and tangent. So we don't need to do sum and difference formulas for secant, cosecant, and cotangent, none of that stuff, because that's all basically take their reciprocals and now you're using the sine, cosine, and tangent double angle sum and difference formulas. All right, so let's do this. Find the exact value of, let's do sine 75 degrees and tangent of 75 degrees. We already did cosine of 75 degrees. We knew what that number was. We can do that if we wanted to. But just using our formulas for this, sine of 75, we know we could rewrite again as 45 degrees plus 30 degrees. Now I can say 30 degrees plus 45 degrees. It doesn't matter, right? It's the same thing. All right, sines on the outside. So sine of 45, cosine of 30. Same sign. So this is going to be a cosine of 45 now and a sine of 30. You'll see a lot of these problems are always going to be very similar in format as far as your answer. Square root of 6 plus 2 all over 4, or square root of 6 minus a 2 all over 4, something like that. So again, you got to be really careful with your signs here. Make sure you evaluate everything correctly. All right, so this is square root of 2 over 2, right? Cosine of 30, square root of 3 over 2, plus square root of 2 over 2 again, and a 1/2, and you see that that is the square root of the 6 plus the square root of the 2 all over the 4. So straightforward, very simple. We can do tangent of 45 degrees plus the 30 degrees. Don't make the mistake of distributing the function tangent across the parentheses. You can't do that. Tangent is a function, it's not a number. Only numbers get distributed across, right? Parentheses. This is tangent of 45 degrees, right? Plus the tangent of 30 degrees all over 1 minus the tangent of 45 times the tangent of 30. All right, evaluate all this. Square root of 2 over 2. No, that's right. That's sine, sorry. Tangent of 45 is sine over cosine. Both are the same, so that's equal to 1. The tangent of 30 degrees. Hopefully you've got it memorized so you can do it quickly, but if not, you can always derive it from sine over cosine. Sine of 30 is 1/2. Divided by the cosine of 30 is square root of 3 over 2. Do the arithmetic. You will get a square root of 3 over 3 once you rationalized it. All right, so from here I have a complex fraction. We want to simplify this. We don't leave answers as complex fractions. So the way we clear the complex fraction is look at the denominators and find a common denominator. Denominator 1, 3, 1, 3. Common would be just 3. So everything gets multiplied by 3. And this will clear out the complex fraction. This gives us the 1 times 3 is 3. This 3 cancels with that, leaving just the square root of 3. Bottom is 3. Same thing, those two cancel, minus the square root of 3. So that's the simplified exact value of the tangent 75 degrees. You can verify that in the calculator. Make sure we did it right. If I did it right, therefore I know my formula was correct. All right, so that should be the tangent of 75 degrees. It's about 3.73. Please verify that. Tangent 75 degrees. It is correct. Now, suppose I just drew a blank. Can't remember the tangent formula for whatever reason. I can still come up with the exact answer. And the exact answer might be in a different format, but it's the equivalent to this one. I can also say, well, somewhere in the test I already did cosine of 75 degrees. If you recall, you can go back and look at it. It was the square root of 6 minus the square root of 2 over the 4, right? So I can say tangent of 75 degrees is equal to the sine of 75 degrees over the cosine of 75 degrees. So this avoids the entire tangent formula. So I plug in, where's my sine? Right here, square root of 6 plus the square root of the 2 over the 4 divided by the square root of the 6 minus the square root of the 2 over the 4. You do the arithmetic, you instead of division, now it's multiplication, right? Of the reciprocal at the bottom. Those fours cancel, leaving the square root of 6 plus the square root of the 2 all over the square root of the 6 minus the square root of the 2. And you might be like, that doesn't look nothing like the 3 plus the square root of 3. Verify in the calculator too. I changed these. Still get that same number. So both are acceptable, right? But just pay attention to the directions. I may on the test say you must use the tangent formula, okay? If you don't still come up with the right answer, I may give you some partial credit for it if you didn't, but just tangent of the sum of two angles or difference of two angles is still important. All right, let's say given alpha and beta the sine of alpha is equal to 4/5, and alpha is in between pi over 2 and pi. So this tells us what quadrant? Quadrant 2, right? And the cosine of beta is equal to -5/13. And beta is in between pi and 3 pi over 2. So this means we're in quadrant 3, right? Find sine of alpha plus beta, tangent of alpha plus beta, and also what is the quadrant of alpha plus beta? All right, so we need to find sine and cosines of alpha and beta, right? Because all our formulas involve that. And also, we might as well just find tangent too. So sine, cosine, tangent of both of these angles. So let's start with alpha. We already have sine of alpha is 4/5. Keep in mind what quadrant we're in, quadrant 2. In terms of x, y's, and r's, sine is y over r, right? So we need to figure out our x value. So x squared plus 4 squared is 5 squared. So x squared is 25 minus 16 is 9. So x is either positive or -3. Quadrant 2, is x positive or negative? X is positive. So now we can say we've got the cosine of alpha, we know is x over r. So that's a +3/5. Tangent of alpha, it's y over x. Y was 4, x was 3, 4/3. Look at beta. Again, keep in mind beta is in quadrant 3. We were given cosine. It's -5/13. And again, cosine is x over r. So we need to find y. So that's -5 all squared. Make sure you put that in parentheses, right? To square it, so we get a +25. Plus y squared is equal to 13 squared. That's 25. This is 169. 169 minus 25 is 144. These are really nice numbers, Pythagorean triples. They work out really nicely. You get some nice whole number or integer values out of these. All right, so therefore y is technically plus or minus 12, right? And let's make the decision of which one to choose because we're in quadrant 3. Y is going to be negative. So now I can say what is the sine of beta is y over r, which is -12/13. And also the tangent of beta, y over x, negative 12 over negative 5 is positive 12 fifths. That makes sense. Tangent is positive in quadrant 3, right? All right, so now we just apply the formulas and just plug in all of these numbers into those formulas. Sine of alpha plus beta is sine of alpha times the cosine of beta, same sine plus cosine of alpha, sine of beta. All right, just go pick up your values. Sine of alpha, 4/5. Cosine of beta, negative 5/13. Cosine alpha, 3/5. Sine beta, negative 12/13. So that makes negative 20, 65ths, minus 36, 65ths, which is a negative 56. Hold on. I put negative right here. Hold on, I think I got a mistake. Negative 3/5. My cosine alpha. Right, either I made a mistake or my example I'm looking at made a mistake. Let's see, hold on one second. 4/5, negative 5/13. I've got these backwards. Negative 3/5 for cosine. It shouldn't be. Oh, let's see what we did. Quadrant 2, x is not positive. Why I chose that? Quadrant 2, x is negative. Right there. So x is negative in quadrant 2, right? Y is positive in quadrant 2. All right, so this should be a negative right here, 3/5. See how easy it is to make a simple sign error. As far as the formulas themselves, most people can memorize the formulas, so it's not that big of a deal. But a simple little sign error can throw everything out of whack. All right, so now that's going to be plus instead, right? Plus 2 negatives multiplied is positive. All right, so that gives us 16 65ths as our final answer. Next, we were asked to do tangent of alpha plus beta. So that's tangent of the first plus tangent of the second, all over 1 minus tangent of the first, tangent of the second. And we've got to have that error right here as well. That x right here is negative, so I better put that as negative for tangent. So tangent of alpha is negative 4/3. Tangent of beta is 12/5. All over 1 minus the product of those two. All right, so let's go simplify just a little bit first, and then we'll clear out the complex fraction. So this would be minus a negative product makes plus, right? And that's going to be 48/15, right? We're going to clear out the complex fractions. Common denominator of all fractions in there would be just a 15. So multiply everything by 15. And cancel some things out. 3 goes into 15 5 times. 5 into 15 3 times, 15 into 15 one time. So that makes negative 20. Negative 4 times 5 is negative 20. 12 times the 3 is 36. 15 plus the 48. So that gives us 16 over 63 for the tangent. All right, so with this information that we found the sine and the tangent, both are positive, right? So sine is positive in quadrant 1 and in quadrant 2, right? Tangent is positive. Tangent is positive only in quadrant 1 or in quadrant 3. So therefore, a plus b, which one is it? Quadrant 1. So a plus b is in quadrant 1. Now we could have also started off at the beginning and kind of get an idea of what possibilities that a plus b could be in. If you look at these two right here, if you add them up, pi over 2 plus pi, that's 90 plus 180. That's 270, right? This is pi, 180, and 3 pi over 2, 270. So 180 and 270, that is 450 degrees. So between 270 and 450, that's from here to here. So you had these two options can be possibilities of whatever alpha and beta are. Now we don't know specifically what they are. We can find that out, but that's another lecture. Okay. Any questions? It looks so excited. They're just that mesmerized, like, wow, this is like mind blowing, right? Just